Hi, seventh graders. Feels like it's been so long since I've done a video for you guys. You'll notice that I'm in my Green Bay Packers shirt, my jersey today, because today's Monday and it's sport and hobby day. So of course I'm repping it. But by the time I send this video to you, it'll be Tuesday, which is pet day. So come on up and say hello. Come Come here. Oh, that's a good boy. Oh, you're a good boy. Today's all for you. It's pet day for you. And I get to flood the internet with pictures of you because it's pet day. Yay. He's happy about it. So, pet day. I hope you guys are enjoying Spirit Week and you're doing some really fun stuff. I'm excited for face paint day because I have to make my own face paint because I don't have any. I'm kind of excited, like a little crafty, and I hope it doesn't stain my face permanently. How hilarious would that be? Anyways, next week you guys are going to start into statistics. This is the last of the geometry that we're going to be doing together. I do want you to start thinking about something that you'd be interested in researching for statistics. Now, it could be your passion project that you're doing for Miss Chamberlain. It can be the science project that you were doing for science. But something that you might be interested in finding a little bit more about the statistics for it. And I'm going to give you a list of things from, but I want you to kind of have some fun with it and think about what would be really interesting to you. So we're going to start that next week, and it's going to take us till the end of the school year, and you're going to do a pretty big project on it. So I just want to wrap up geometry real quick before we start that. And one of the things that we kind of brushed on a little bit was similarity between the triangles, and I wanted to revisit it because similarity is really cool because it kind of wraps in a few things that you were working on last year with your geometry and your house building with scale factor, and that's a really big part about this. So we're going to do this real quick, and then you'll have some activities to practice and play around with it too. So similarity. So kind of similar to congruency. Now, when we were talking about two things being congruent, let's say if I wanted to say like line AB, right? And remember we have to do the little arrows to say it's a line, and I want to say it's congruent to line DE. I would use this symbol. It's an equal sign. Sorry, it's so excited. It's an equal sign with a little squiggle over it. This means congruent. When we're talking similarity, and similarity between two things doesn't mean that they are the same exact length. Saying two lines that are congruent means that they're exactly the same length. Saying they're similar doesn't make any sense because lines are all similar with each other, because similarity means that they look the same, they're a different size. Similarity means they look the same, but they're a different size. So all lines are similar. So we don't talk about lines being similar. We do talk about shapes being similar. So maybe I can say a triangle, and I'll do a little symbol, and you'll see this sometimes. You'll see triangle ABC is similar to triangle, oops. Yes, I blew on it. It's to draw it, so I can erase it there. DEF. That symbol means similar. And you have it on your keyboard. I know you do, because a lot of you like to make fun little emojis with them little squiggle faces. So that little squiggle means similar. Similar means looks the same, different size. Okay, now with triangles, in order for triangles to be similar, they have to have the same angle measures. And we talked about that a little bit with some of the stuff you were doing last week and the week before, that you can determine triangles being similar to each other if at least 2 out of the 3 angles are the same. Now, if they're at least 2 out of the 3 are the same, you know the third one is going to be the same because we know all the angles inside of a triangle always add up to 180 degrees. So we kind of have a good idea about how triangles are going to be similar to each other. We know that their angles all have to be the same. And if their angles all have to be the same, then I know that the triangles are similar because the side lengths to create those angles are going to have to be similar to each other. And they're going to have a scale factor with them to create the either small triangle or the big triangle, right? But as long as the angles are the same, they're similar triangles. So let's now talk about maybe a different shape. And the shapes I chose today are squares. I drew these squares. I lost my eraser. Pause. I'm back, sorry. Okay, so I drew these squares using a ruler, and I measured them. My first square here is 12 centimeters by 12 centimeters. And because we've been talking a lot about like labeling them, I am going to label the vertices so I know which square I'm talking about. So this one is going to be A, B, C, D, and we'll make this one E, F, G, H. Okay, I just labeled the vertices here. Okay, so triangle ABCD is a 12, not triangle, square. Square ABCD is 12 centimeters by 12 centimeters. We know then the other two sides are also going to be 12 by 12. What do we know about the angles? And you think, what do we know about the angles inside square? They all have to be square. They all have to be right angles. Yeah, so we can draw little tiny right angles in all of these little angles here. Because if it's a 12 by 12 square, they have to all be square angles, right angles. Okay, so then I look at this big guy. It's still square. It's an 18 by 18 square. What do I know about all the angles? They have to all be 90 degrees, right? They all have to be right angles. So I can go ahead and do that too. Okay, so something cool here is happening. Now, if all the side lengths are the same between them and all the angles are the same, then we know that they'd have to be congruent, right? Well, now I've proven all the angles are the same, just like with the triangles, that their angles are the same, they're similar. My angles are the same here. Do you think we can determine that they're similar just based on that? No, we can't. And the problem with that is because we've got this additional side. With triangles, there's only three sides, and there's so many rules about triangles when you're building them, right? We know that two sides added together can't be more than the third side and things like that. So because there's so many rules in building triangles, just knowing the angles are enough for us to determine that they are going to be congruent. I mean, similar. But here, because we have this additional side, it messes things up. Knowing that their angles are going to be the same is great, but if I drew a square and then I drew a rectangle, well, regardless that all four angles are all 90 degrees, these two are not similar because they don't look the same. So just because their angles are the same doesn't mean we can prove congruence as similarity. To prove similarity, we need to know that it grew or shrunk by the same amount. All the sides need to grow or shrink by the same amount, and that's called scale factor. And I hope that reminds you a little bit of last year when I had you doing some scale factor. So we need to determine if all of the sides that are supposed to coincide with each other have the same scale factor. So let's take this side, for example. We want DC to coincide to HG, just by how these two things are drawn, to determine that they're similar. If this side is similar to this side is similar to this side is similar to this side, and so on, then we know the whole entire shape has to be similar to each other. So we got to figure out if this is similar to this. In order to do that, we want to figure out the scale factor. If the scale factor going from side DC is the same, or sorry, from going from DC to HG, is the same scale factor as going from AD to EH and from AB to EF and so on. If the scale factor is the same for all of the sides, they're similar. And that's what we want. So we got to figure out what the scale factor is. So this side was 12. And this side is 18. And I'm going to set it up as a ratio because we can represent scale factors as ratios, okay? So it's a 12 to 18 ratio. Can I simplify this ratio? Yes, Ms. Rock, absolutely. Let's simplify it. I can make it 6 to 9, right? By reducing both sides, it's 6 to 9. Ooh, they're both divisible by 3, aren't they? So I can make it a 2 to 3. So the ratio is 2 to 3. Now, if I really wanted to know like what the scale factor is, like what I multiplied by, I can change this to a 1. That would be cutting this in half. which means I'd have to cut 3 in half, which would be 1.5. So that right there, because this is 1, that is my scale factor. This side of 12 was multiplied by 1.5, 1.5, to get 18, because 12 times 1.5 is 18. Okay, so that's my scale factor, but I would stop here at this ratio and say the ratio between these sides is a 2 to 3 ratio. Scale factor, 1.5. Now I'm going to check this by using this process for the other sides. Luckily for us, and because I want to make this video a little bit shorter than all my other videos, all the sides are the same because they're squares. So that means that this one is also going to be 12 to 18, and I can do the same process. And the other ones are going to be 12 to 18, and I can do the same process. The cool thing about squares, all squares, as long as they're square, all squares are similar to each other. Unless they have the same size, then they're congruent. So we just proved that these two things are similar. Okay, you can use the same process with rectangles or trapezoids or rhombuses or any two shapes, as long as they're telling you information like we need to make sure all the angles inside are the same. So if I have two rhombuses, the angle in the first smaller rhombus needs to be the same as the angles in the bigger rhombus. And then the sides need to have the same scale factor. Okay, the ratios need to all be the same. Proportional, right? Equal ratios, proportional. So using that information, you guys can hopefully be able to figure out similarity between any two shape, and that's going to be some of your work that you're doing this week. So if you have any questions, as always, you can email me or send me a quick message, and I look forward to hearing from you guys this week. Bye. Enjoy Spirit Week.